Hello and welcome to about application of quadratics. Now, some people usually freak out when they see the word application because, well, like we've done in previous section, application usually means word problems. Dun dun dun. But I want to kind of emphasize the importance of application. It can be anything in your life. If you learn some true principle or just any concept, maybe it's educational or spiritual or psychological, it doesn't matter what it is. If you never apply those topics, then really you haven't learned it all. I love Stephen R. Covey. Stephen R. Covey is a member of the church. If you haven't read his book or seen a video, I posted a link for you. You don't have to watch it if you don't want to, but about his steps to becoming highly successful. It's been talked about a lot, both in the church and outside of the church, what you got to do to become successful. He's got a great quote. It says, "To learn and not to do is really not to learn. To know and not to do is really not to know." So it's super important when we learn a true principle that we do apply it to our lives, that we do it. If not, we really haven't learned it. And if we do something, or we know something and we don't do it, then we really don't know it. Important principle there. So with the math today, what we want to do is do a little application. We want to apply some of the things that we've learned to some real life situations and see how it goes. There's four situations that we want you to know on how to apply quadratics. The first one is a geometry type equation. Number 2 is just dealing with an equation. Number 3 is with consecutive numbers. And number 4 is with the Pythagorean theorem. So let's go ahead and take a look at each one of these individually. Okay, so in geometry type questions, basically we're just going to be dealing with area. In previous chapters we dealt with perimeter, but with these type of questions we'll be dealing with area. Here's an example. It says the length of a rectangle is 3 more than 2 times its width. If the area is 90 square feet, what is its length? So to do this, it's always good to draw a picture. So I've drawn a picture here. We've got a rectangle. I know that the width is some value. I'm going to go ahead and put x. And the length is a little more than the width. Let's say it says the length of the rectangle is 3 more than 2 times its width. So that would be 3 more than 2 times the width. That makes sense? So we write out the triangle here, and now we can move on to the next part. It says if the area is 90 square feet, we know that the area of a rectangle is length times width. So the area of this rectangle is simply the length, which is 3 plus 2x times x. And they even told us what the area is. The area is 90. So we go ahead and just write in each of these steps here to work on solving these types of application problems. From here, we can just simply distribute the x in. So I get 90 equals 3x plus 2x squared. And now we're exactly where we were in our last video on solving quadratics. To solve a quadratic, we got to get everything to one side. I'm also going to put this in order. So I'm going to subtract the 90. I get 2x squared plus 3x minus 90. That equals 0. Once we get everything to one side, we then factor. I'm going to have to factor this using the AC rule because the first value is 1. So let's see. 2 times 90 is negative 180. I need the factors of negative 180 that add up to 3. So let's start writing them out. Let's see. There's 10 and 18. No, that doesn't work. There's 5 and 36. No, that one doesn't work. Let's try 9. 9 and type this into my calculator. 20. That doesn't look good either. What about 12 and 15? Ooh. Now this looks good because we're trying to get this equal to 3. So I'd make the 12 minus. That's going to work. We're going to use 12 and 15. So we rewrite the polynomial using, remember, AC rule. You got to rewrite 12x plus 15x minus 90. These were the factors I used right here. I then cut the problem in half. Over here I take out a 2x, leaving me with x minus 6. Here I take out a 15, leaving me with x minus 6. And so my factors are 2x plus 15 and x minus 6. And these equal 0. Wow, I did not leave very much room here. The last step when solving polynomials is to set each of these equal to 0. So I'm going to come up here and do it up here. I get 2x plus 15 equals 0. And then I get x minus 6 equals 0. So here I'm going to subtract 15 and divide by 2. So I get negative 15 over 2. Here I'm just going to add 6. I get x equals 6. So we are left with two answers, just like always. We always get two answers when solving a quadratic. However, when dealing with word problems, we're usually only going to pick one of the answers. That's not always true, but in this situation, we would never use negative 15 halves. It just doesn't make sense. This is a bad answer. You can't have a width of negative 15 halves. So the only answer that makes sense here is 6. And so this tells us that our width is 6 feet. And the length, if we plug it back in here, if we plug 6 right here, would be 15. And so our answer, since they were looking for the length, is x equals 15. So again, you just want to set up the problem, factor it out, set the factors equal to 0, and then identify which answer you're dealing with. Let's have you guys try one of these rectangle problems. Okay, so here's one for you. The length of a rectangle is 7 more than the width. If the area is 44, what is the length? Go ahead and pause your video, work on this in your video notebook, and when you're ready to check your answer, go ahead and push the play button. Okay, let's take a look. So I've got a rectangle here, and I know that we've got a length, and we know that our width, and we know that the length is 7 more than that. Okay, so when I do area equals length times width, and they've told us that the area was 44, the length was x plus 7, and the width is x. So I get 44 equals x squared plus 7x. I get this equal to 0, and I'm left with x squared plus 7x minus 44. So if I want to factor this, I need to use I don't need to use the AC rule since the value here is 1. I just need to find the factors of negative 44 that come up with 7. Let's see, there's 2 and 22. That doesn't equal 7. There's 4 and 11. Ooh, 4 and 11 is going to work if I make the 4 negative. Okay, cool. So this factors to x minus 4, x plus 11. I now set each of the parentheses equal to 0. X minus 4 equals 0, x plus 11 equals 0, and I get x equals 4, and x equals negative 11. So, we don't use the negative answer, it just doesn't make sense here. So the answer obviously is 4 for the width, which means the length, when we plug 4 back in here, is 11. So we should have said that the length is 11 units, or 11 feet, or 11 meters, whatever the units were. Okay, great. That's the first type of problem. So we talked about geometry problems. The next problem we want to talk about are equation problems. These are probably the easiest type because they actually give you the equation right in the problem, which is really nice. So for example, let's say they would say, you know what, the number of games played in a league, in a volleyball league, is x squared minus x, where n equals the number of games and x equals the number of teams. So they'll always give you an equation in these types of problems, and so pretty much it's just plug and chug. In this one they say, hey, part A, how many games will be played? How many games will be played? Will be played if there are 7 teams, or let's go with 8 teams. If there are 8 teams. Now the key to this kind of problem is making sure that when you get the equation, you know which each of the letters stand for. And that's why I wrote it out here. N is the number of games, X is the number of teams. So for part A, if they said how many games will be played if there are 8 teams, we're going to plug 8 in for what? Are we going to plug it in for X or plug it in for N? Well, they said there's 8 teams. And so we would plug it in for x. So I get n equals 8 squared minus 8. So n equals 64 minus 8, which means n equals 56 games. So in the tournament, there would be 56 total games under this situation for them to all play each team twice. So that's pretty easy. That's just plugging in the number 8 and getting it. But part B requires a little more work. So in part B, they tell us the total number of games. They say, okay, we've got this tournament coming to town. There's going to be 110 games. In this situation, how many teams are there? So 110 games. Now, are we going to plug in 110 for n or for x? Hopefully you're saying n. In the last one, we plugged it in for x. In this one, we plug it in for n. And so now that we've got that, we plug 110 in. I get 110 equals x squared minus x. Now, anytime we have an x squared and an x value, the way to solve this is using factoring. So we're going to have to get everything equal to 0. So I subtract the 110 over, and I get x squared minus x minus 110. 110. I then factor this. So I've got to factor. I've got to find the factors of 110 that come out to be 1. Ooh. Let's write some out here. We've got 2 and 55. We've got 5 and, better use my calculator, 5 and 22. 10 and 11. There's, oh wait, 10 and 11 looks good because we want it to equal negative 1. So if I made the 11 minus, that would work. Sweet. So it factors to x plus 10 and x minus 11. Then to finish solving, we set each parenthesis equal to 0. X plus 10 equals 0. X minus 11 equals 0. So we get x equals negative 10 and x equals 11. The negative answer here doesn't make sense. We can't have negative 10 teams. So we just cross it out and we say that our answer is 11 total teams. So another real life application is with quadratics are anything under gravity, believe it or not. Anything under the influence of gravity forms a parabolic or a parabola, and these are second degree polynomials, which is kind of cool. Let's pretend for a moment that we've got an angry bird, and we know that the height of the angry bird can be modeled by the following formula. 120t minus 16t squared. In this equation, h represents the height in feet, and t represents time in seconds. Time in seconds. So what we'd like you to do is answer these two questions. I just did one just like this with the games. We're going to give you a slightly different equation. See if you can do it. So part A says, find the height of the angry bird after 3 seconds. So after 3 seconds of being launched, what is the height of the angry bird? Question B then asks, if the height of the angry bird is 176 feet, how long has it been in the air since the launch? Go ahead and pause your video and give these a try. See if you can answer these angry bird questions. Okay, so how'd you do? So on this one, again, remember t represents seconds and h represents feet. It's always super important that you understand what each letter represents because it'll help us when solving these problems. In A, it says that the bird has been launched for 3 seconds. So we're going to plug 3 seconds in for t, you bet. H equals 120 times 3 minus 16 times 3 squared. Make sure to follow order of operations, doing exponents first, which gets us h equals 120 times 3 minus 16 times 9. We then can go ahead and use a calculator. I've got one here in my hand. I'm just going to go ahead and type it out. We find out that the bird has been in, that the altitude or the height of the bird is 216 feet. Okay, sweet. So that was just plugging 3 in for t. Now in part B, they gave us the height, 176 feet. So we plug that in for h. I get 176 equals 120t minus 16t squared. We're going to have to go ahead and get everything on one side. So I get negative 16t squared plus 120t minus 176. Now this is a pretty heavy-duty AC rule here. We got to take 16 times 176. We get 2,816. We got to find the factors of that to get us 120. I've gone ahead and found a couple here. It took me a little while. I did have to write out a bunch of numbers. The one that really works, though, is 32 and 88. Those are the ones that work there. So I would have to rewrite this polynomial. So I'd write negative 16t squared plus 32t plus 88t minus 176. I'm running out of room. But once you go ahead and finish factoring this using grouping, you get 0 equals negative 8. There's some common stuff you had to factor out. And 2x minus 11. And so we set each of the parentheses equal to 0. And I get x equals 2 and x equals 11 over 2. And those are our two answers. Believe it or not, the Angry Bird hits 176 feet twice, at 2 seconds and also at 5.5 seconds, which kind of makes sense. If you come up here to the graph and you say, wow, let's say that this is 176 feet. Well, notice that when it goes up and then comes down, it passes by 176 feet twice. So in this situation, both answers make sense, and we say both those answers are good. Okay, great. That's it for equation types of problems. Okay, let's go to consecutive integers. Now, we've already talked about consecutive integers in this class. Consecutive integers are just ones that go right next to each other. So, for example, 5, 6, 7. These are consecutive integers. And when we do it in math, we have x, x plus 1, x plus 2, and so on. And so consecutive integer number questions aren't too complicated. Here's an example of one. A book is opened up so that 2 pages are showing. The product of the page numbers is 210. What are the page numbers? So in this situation, we just set it up. Keyword here is product. Product means multiply. And we know that these are consecutive numbers because if you're on page 7, then the next page is 8. Or if you're on page 9, then the next page is 10. And so basically, we're going to let x represent the first number, x plus 1 represent the next page number, and we know that when we multiply those, it comes out to be 210. So again, after you've set it up, you can just simply distribute. We get x squared plus x equals 210. We subtract the 210. We then factor it. Ooh, factors of 210 that get me 1. Well, there's 2 and 105. That's not very good. There's 10 and 21. There's 14 and 15. Ooh, 14 and 15 works. Again, it can help to bust out a calculator and work on typing these all out, making sure that you get it. So that's those are my answers there. I need to make one of them negative. This needs to equal a positive 1 because that's what the b term is. So I'm going to make 14 negative. So I get x minus 14, x plus 15 equals 0. I set each of these equal to 0. X minus 14 equals 0. X plus 15 equals 0. And I get 14 and negative 15. Negative 15 is not a very good page number. Ooh, that'd be bad if you're in the negatives. What page are you on? Negative 7? Ooh, no, don't do that. Our answer here, the first page was 14, which means that the next page number is 15. And so our answer is that you opened up to page 14 and 15. And if you multiply 14 times 15, you'd find out that that equals 210. So that's a consecutive number problem. Okay, so take out your video notebook. Here's a consecutive number for you to try. It says here, the product of 2 consecutive numbers, ooh, keyword product, is, oh, don't forget what is means in math, is 11 more than the sum of the 2 consecutive numbers. So sum. So we got the word product and sum there. Oh, okay, interesting. You need to find the 2 numbers. Go ahead and pause the video, give this a try, and when you're ready to check your answer, push the play button. Okay, let's take a look at this one right here. Let's use orange. That looks like fun. It says the product of 2 consecutive numbers. So let's write out these numbers. I'm going to call the first number x, and the next number x plus 1. These are my two numbers, okay? So it says I've got the product of two consecutive numbers, so that means multiply them together. I've got x times x plus 1. The product of two consecutive numbers, I've got that, is always means equals 11 more than the sum of those numbers. Okay, so sum means addition of these numbers, so 11 plus x plus 1. Okay, sweet. So now I need to find what those numbers are. So let's go ahead and do a little math here. I'm going to go ahead and distribute the x here. I get x squared plus x when I distribute this in equals, I'm going to combine the like terms. X plus x is 2x, and 11 plus 1 is 12. Now when solving polynomials, we always get it to the same side. So I'm going to subtract this over. I get x squared minus x minus 12 equals 0. I subtracted the 12 over, subtracted the 2x. I'm going to factor this. Factors of 12 that get me 1. Seems like 3 and 4 work with a negative 4. So I've got x minus 3, x plus 3, x minus 4 equals 0. And so my answers are x equals negative 3, because I set this equal to 0, or x equals 4, because I set this equal to 0. And so these are our answers here. X could equal negative 3, which means the consecutive number would be 1 plus that. So that could work. Your answers could be negative 3 and negative 2. Or if x was 4, we could have 4 and 5. Either one of those solutions would work for this situation. Okay, the last thing we want to talk about is the Pythagorean theorem. Now, when a lot of people think about the Pythagorean theorem, they think of this example right here, where you're given a triangle and you're asked to find x. And everybody always just circles the x and says, there it is! I have a shirt that's like this. Really funny. But that's not what it's asking for. When we're doing the quadratic, the Pythagorean theorem, the Pythagorean theorem states that if you take any two sides, say this was a side of a triangle, and this was a side of the triangle, then therefore a squared plus b squared would equal the hypotenuse. Now the hypotenuse is the longest side. Don't abbreviate. Hypot doesn't sound good. Hypotenuse. It's always the longest side of the triangle. It's the one that does not touch the 90-degree angle. And so a squared plus b squared equals c squared. So if we were to actually find what x is, we could plug these values in. I'd plug 3 in for a, 3 squared, plus plug 4 in for b equals c squared. I would get 3 squared, which is 9, plus 4 squared, which is 16. That equals c squared. 9 times 16 is 25, equals c squared. Now to solve for c, to get c by itself, we have to do the opposite operation of a squared. Notice that we have c squared. So what is the opposite operation of a squared? Well, the opposite is a square root. So just like the opposite of addition is subtraction, and the opposite of multiplication is division, the opposite of a power is a root. So we can root both sides of this equation, and the root will cancel the power. So this root cancels that power, and we're just left with the answer 5. C equals 5. So that's how you do Pythagorean theorem. It's leg squared plus leg squared equals hypotenuse squared. Let's go ahead and give you guys one problem to try. Okay, here it is. It says to find x, and no, you can't just circle it and say here it is. That doesn't work. We want you to use the Pythagorean theorem to try to figure out what the x value is. Go ahead and pause the video and use the formula a squared plus b squared equals c squared to find what x is. Okay, how'd you do? Again, it's just leg squared plus leg squared equals hypotenuse squared. So one of the legs is x, so I'm going to put x squared here. Another leg is 12, so I'm going to put 12 squared there. And the hypotenuse, remember, that's the longest side that's not touching the right angle. So that's the hypotenuse, is 13 squared. So I'm going to go ahead and work on solving for x. I get 144 equals 169. Okay, good. We subtract 144 over, so subtract a 144 to both sides. I get x squared equals 169 minus 144 comes out to be 25. I root both sides, and we get x equals 5. Okay, sweet. So on this problem, that leg has a length of 5. So there's real-world problems we can do with this. Ladder problems are usually Pythagorean theorem problems. If you've got a 10-foot ladder and it's set 5 feet away from a building, well, how high up can you get on the building? Well, you guys should try this one. Go ahead and pause the video, use the Pythagorean theorem, and see if you can't figure out what the height, how high this ladder would go up. Okay, how'd you do? You should have, again, Pythagorean theorem is leg squared plus leg squared equals the hypot squared. And in this situation, the ladder is the hypotenuse, so I'm going to put 10 in for the hypotenuse. 5 is one of the legs, and h is the other leg I don't know. Okay, so we can now go ahead and square all these. I get 25 plus h squared equals 100. I subtract the 25 over. I get h squared equals 75. Square root both sides to undo it. And I get the square root of 75. Ooh. Now, that would be a good answer, but usually, I mean, you wouldn't want to tell your boss, hey, the ladder goes up root 75. That's not a very specific value. You'd probably want to go ahead and plug that into your calculator and figure out what root 75 is. So find the square root button on your calculator, and you find out that it goes up about 8.66 feet on the building. Now, this concept can be taken one step further, and that's where we'll stop for the day, with this one additional concept, where we can actually have algebra situations placed in a Pythagorean theorem situation. For example, I can basically say, hey, what if this side were x, and this side were x plus 7, and we knew that the hypotenuse had to be 13. Could you solve for x and find out what the length of this of the base and the height are? Well, of course you could. You could use the exact same thing. For example, leg squared plus leg squared equals hypot. Hypot. Sounds funny. Hypot squared. Again, we're just going to plug in the value. So this is a leg, so I get x squared plus this is a leg, so that's x plus 7 squared equals hypot, which is 13 squared. We can go ahead and work on solving for x. So here I get x squared. Here we're going to have to write x plus 7 times x plus 7. Don't forget, you can't square. Ooh, I worry that some people would say that that is x squared plus 49. Ooh, that's not right. Remember, you got to write it out twice and then super distribute. When doing that, I get x squared plus 7x plus 7x plus 49 equals, what's 13 squared? 169? Yeah. Okay, good. Again, we're going to want to get everything to one side. I got 2x squared plus 14x. I'm going to minus the 169 over, and I get 49 minus 169. I get negative 120. That equals 0. There's some common stuff here. I'm going to factor out the 2, leaving me with x squared plus 7x minus 60 equals 0. I need to find the factors of 60 that add to 7. So there's, 3 and 20. There's 6 and 10. There's 5 and, what does that come out to be? 5 and 60 divided by 5. 5 and 12. Ooh, I think I can get a 7 there, because this is negative 60. So to get a positive 7, I'd make the 5 negative. So this comes out to be x minus 5, x plus 12. And so as I set each one of these equal to 0, I get x equals 5 and x equals negative 12. That's negative 12 doesn't make sense, but 5 does. That tells us that this length is 5 and that this is 12. Okay, well, that is it for this lesson. This was a long one. Again, application. It can take a little while, but when you can apply things to your life, that's when you can truly master them and understand those concepts. So you can continue on to the lesson. Thank you for watching, and thanks for being in the class and watching all these videos. We hope that it's been an enjoyable experience for you, that you've been able to establish yourself with some math concepts, and we wish you luck in all your future math classes. Thanks for watching.